Jai Jarendra, Namaste, welcome to my channel. Today we will be solving the 15th question of the problem solving series, the placement series, which is based on arrays. This question's difficulty level is easy, and this question has been asked in Microsoft, Google, Goldman Sachs, Amazon, and multiple companies. So let's begin. Wave array. Let's look at the example. So we need to get this is the array which is given 1 2 3 4 5. We need to change this, short this array in a wave form. So what is wave? In wave we see that value is going up, then goes going down, the next value is up, then it's down. So in this way we need to short our array. What does this means? This means that the A80 element will be greater than A1, and the A1 will be smaller than A2, and then A2 will be greater than A3, and A3 will be smaller than A4. In this way we need to arrange our given array. So for this example 1 2 3 4 5, we see that this 1 is smaller than 2, which we don't want. We want that the first element or the 0th index element should be greater. So what we'll do, we will change it. So this will become 2 and this will become 1. Now if we again write this 3 4 5, does this satisfy our condition? So 2 is greater than 1, 1 is less than 3, but 3 is again less than 4. So this is not right. So what we'll do, we will change this and we will make this as 4 and this as 3. So 4 3 5. Now this condition is satisfied. 4 is greater than 3 and 3 is less than 5. So in this way we will be returning this array. We will change this array to 2 1 4 3 5. Similarly, in this question 2 4 7 8 9 10, what we are going to do, we need to change it as 4 2 8 7 10 9. Then whatever we get here will be in this form. 4 is greater than 2, 2 is less than 8, 8 is greater than 7, 7 is less than 10, 10 is greater than 9. So this will be our answer. So now how do we solve this? We are given the size of the array or vector, and we are given the vector. We need to short this in the form of an wave array. So what is the approach? How do we solve this? Normally when we are given to short, we use the sorting algorithms and we can, or the sort function directly, and we can short it. But how do we ensure that this is in the wave form? What could be the approach? So one of the approach is, if we short this element, these elements are already sorted, but we might get an unsorted array elements, right? Anything 5 15 and then 193, then 4 3 8 9, anything. So that point of time we have done it directly, but for those elements, if we short it and we'll get it in this way, and then what have I done here? I am checking 1 and 2, and then if this 1 is less than 2, then I have swapped this 1 and 2 and have come to, we have got 2 and 1. And then what I have done, I have directly jumped to this part. Why? Because I know this 2 and 1, if 1 is less than 2, then 1 will obviously be less than 3, right? Because this is shorted, 1 is less than 2, 1 is less than 3. So if I swap this 2 and 1, I don't need to care about the relationship between 1 and 3, because I know this 1 will obviously be less than 3 because 1 was lesser than 2, right? So what we can do after sorting, we can directly go to the second part of the element, right? 3, and I can check whether this element is lesser than this element or not. So here we see that 3 is not greater than this next element, so we can replace this again. So again we have replaced this 4 and 3, and then we have moved to 5. So in this way we can sort the array, and then we can move to the next part of the element, and so we'll sort the array, and then we will see uh, this we will swap these elements after sorting, and then we will move to the next element every time, because once it is swapped, this relationship is already there. So what is the first way we can solve it? We have got this array over here. What we can do is we can, this is not working, so let's use this. So we will short this array dot begin array dot end. So we have the sorted array now. Now what we will do? We will traverse this array 0, 2 and minus 1, and then okay, for I equal to 0 equal to n minus 1, swap of ai comma ai plus 1, because every time ai will be less than ai plus 1, and then we will increment I is equal to I plus 2 instead of 1. So here it would jump over here directly. So for example, this one, when we, so this 2, 4, 7, 8, 9, 10 is already sorted. Suppose we get another example as say 9, 2, 5, 3, 4. Okay. So in this case, 9 is greater than 2, 2 is less than 5. So this is fine. 5 is greater than 3, but 3 is not greater than 3 is okay. 4, 3, right? So 5 is greater than 4, but 4 is also greater than 3. So this wave, this is not a wave array. So what we will do? We will sort this. So if we sort this, then it becomes 2, 3, 4, 5, 9, right? After sorting. Once we have got this, now what we will do? We will swap this 2 and 3. So it will become 3, 2, and then we will move here directly 4. So we will swap this 4 and 5 to 5, 4, and then we will move this 9. We don't have anything, so it will be 9. So here in this case, 3 is greater than 2, 2 is less than 5, 5 is greater than 4, and 4 is less than 9. So this is what we have done over here. We don't need to return anything because we have passed it as a reference. So in this way, we can solve this. What is the time complexity over here? The time complexity is order of n log n, because we have used the sorting algorithm, and space complexity is order of 1. So the time complexity is order of n log n. Can we optimize this? Yes, we can. We need to observe one thing here, that when for this wave array, this even you can say it as an odd also, but I am considering the index 0, 2, 4, 0 and 2. We can see that this odd position or even position according to index is always greater than the adjacent element. For example, this A2. A2 is always greater than the adjacent values. That means for this even indexed element, the adjacent would be always the odd elements, and this will be greater than A2 will be greater than A1, and A2 will also be greater than A3. Just like the wave, this will be greater than this and this. So can we use this approach or observation to optimize this? We will check every time whether this even position indexed element is greater than its adjacent element or not. If it is not greater, we will swap it and it will become greater. So automatically the odd position elements would be would fall into place, right? For example, 1, 2, 3, 4, 5. Okay, we see this 1. Okay, now if we use this observation, this is a 0, 1, 2, 3, 4. So 0 and 2 are the 0, 2 and 4 are the even indexed elements, right? So we need to check this element is greater than the adjacent element or not. But for this one, there is no left adjacent. So we check the right adjacent. This right adjacent, this is smaller than right adjacent. So we will swap it. Okay, and then we will move to the next even based element. So this 3. Is this 3 greater than 1? Now this has been changed to 1. Yes, 3 is greater than 1. Is 3 is greater than 4? The next adjacent? No, it's not. So we will swap it. 2, 1, 4, 3. And then 5. Is it greater than the next previous adjacent? Yes, it is greater. It doesn't have the right adjacent. So we have solved this. Same is the answer. So in this way, we are not sorting it and we are solving it. We don't need to have the elements in an ascending or descending order. Whatever the unsorted array we have, we can solve this answer like this only. Right? I think the approach is here. Let's code it. So the answer, the coding is very simple. So for I equal to 0, I is less than n, and I is equal to I plus 2, and we will see if I is greater than 0 and array of I is the 0th index we are starting na. If array of I is greater than if lesser than array of I plus 1, we don't want this, then what we will do, we will swap array of I and array of I plus 1, right? If again this swapping is done, now we will check for the, so we have checked for the right adjacent, now we will check for the left adjacent. So for left adjacent, okay, we could have checked I is greater than 0. That means here we need to check it for the left adjacent, right? So for right adjacent, we don't have this, we don't need to worry about this. Even if the I is greater than lesser than 0, even if I is equal to 0, then also we will have the I plus 1. So I need to change this to I minus 1. So I've checked for the left adjacent. Okay, I has to be greater than 0, like this one. So if otherwise, if array of I is less than, okay, here in this case I has to be lesser than n minus 1. Okay, if I is less than n minus 1, because we are checking for the right index, n minus 1, and array of I is less than array of I plus 1, then we will swap array of I comma array of I plus 1. Array of I minus 1. So in this way we will be able to solve this approach. So first is sorting approach. The TC was order of n log n, and with this optimized approach, the TC is order of n, and the space will be order of 1 only, because we have not taken any extra structure. So with in this way we can solve this question. The link to the question has been given in the description. Please try it out yourself and then come to my code walkthrough section.
Here is the code walkthrough section of the 15th question of the problem solving series, that is wave array. You need to sort the vector in the form of a wave. So as we have discussed already, we can solve it in order of n time complexity and order of 1 space without using any extra space, extra map or anything, without shorting it. Like the first approach, we were shorting it and then we were checking the first 2 elements, and directly we were swapping the first 2 elements and moving to the next elements. But we have already discussed one observation. so that we have used this observation that the current even element, if the even elements index element will always be greater than the previous and the next element. So we are comparing here with the previous element, and if it is smaller, if the current element is smaller than the previous, we are swapping it. Same we are doing for the next elements. So in this way we can be able to solve this series. Since it is a void data type, we have passed it as a reference. We don't need to return anything, it's a void. So let's compile and run it directly. It's giving us the right result, so let's submit this. It's got fine. So let me know in the comment section how was the explanation, and we'll see you on the next video where I'll be solving the 16th question of the problem solving series. Thank you.